This tutorial or video is going to step you through a new concept called pointers. It is code that is borrowed from the Dawson Beginning C++ through Game Design book. And we're just going to step through this program. I'll show you what the output looks like. And we will discuss how this output is created and what it means. If you take a look at these values here, the 002CFEEC, that's actually like a memory address. That's the reference. That's an address to where the data is actually stored. And then 1,000 here and the 1,000 here are what we would call their actual values that are stored in what we call a pointer. So the first line in this program introduces us to declaring a pointer, and a pointer is declared using the asterisk. You could actually put a space between the integer data type and the asterisk, or you could put the asterisk right in front of the pointer. It's just kind of a personal preference what you prefer. I'm going to go ahead and just stick with what this textbook has, but that's declaring a pointer, and a pointer is declaring a memory location for you to point to. The second one declares a pointer and initializes the pointer to a value of 0. The third line introduces or just declares a regular integer variable and assigns it to 1,000. The next line is going to use the pointer to a score, and it's going to assign the pointer the address of the score variable. So what happens is, in memory, every time you create a variable, the creation of a variable creates or sets aside a memory. And that memory slot is what's referenced here using the ampersand. So the ampersand, which is above the number 7, assigns pointer pscore the address of the variable score. It doesn't assign it the value of 1,000. If I look back here at the screen, pscore right here is the address of the variable. Ampersand score, which is assigned to pscore, is the address of that variable. If you look, those two addresses are the same. Now the value that's stored in score is 1,000, and if I point to the pscore right here using pscore and this line, this is the value pointed to by the pointer. That's 1,000. You can think of a pointer as, again, a memory location. So pscore is just a memory or a reference. Score has the actual value, and the pointer pscore has this relationship to score where the pointer points to score. And so that's how you can think about a pointer. If we take a look at the next set of lines, and actually let me go back here. So when you use the ampersand, that's going to give you the address, and pscore is also an address because we assigned it this integer pointer. So that little asterisk there indicates that it's a pointer, and then here pscore can be assigned the address to score. So what ends up happening here is if I use pscore, it's going to point to score because it's assigned the address of score. And that's how on the screen we get the value of 1,000 using the pointer to pscore. If we add a 500 to score, which is going to be our regular integer variable, and then we output score and we output the pointer, take a look at that data. What happens is 500 gets added just to score. You might think, well, 500 is getting added to pscore, but what's happening is pscore is actually pointing to score. And so if I change score, the results that are in pscore are also going to get changed. In the next 3 lines of code, or 4, if we add 500 to pscore and output that, same thing. Because pscore points to score, it changes the value in score. If you take a look at this code right here, I did not access the local variable score right here. I used pointer to score and added 500 to it. but because p-score is actually pointing to that memory address, it's linked. It's like a reference, or it is a reference, and so changing p-score also changes score. If we take a look at the next 3 or 4 lines of code where we're going to assign new score to p-score, new score is 5,000, and now I'm going to change where p-score points to. So I'm going to change the reference to p-score to new score, and I'm going to output the reference to new score. If we take a look at that output, the reference to new score is 002CFEEO, which is different than the memory address that we had for score. And now p-score points to that. So the first one was referencing new score. The second one is referencing or showing you what's stored in p-score, which points to new score. And then the actual values that are stored in there are the same. And I shouldn't say values. I shouldn't use plural because it's only one value. The only value that's being stored is the 5,000, and it's stored in variable new score. We can access it directly using new score, or I can use a pointer to that variable. The last set of code here, where I'm going to assign the reference to string to a pointer string, is just showing that pointers will work with strings. And so I've got a string variable, and it has the string score in it. I create a pointer to string, and I didn't mention it before, but naming variables with a P in front of them is a convention that indicates that that's a pointer. So if you look at all of the pointer variables, p-score has a P in front of it to indicate that's a reference or a pointer variable. That's just a naming convention that programmers use. I create a pointer to a string object. I output the regular string as score. If I output the asterisk to, sorry, lost my train of thought. The asterisk p string, that is accessing the actual value. The pointer is pointing to what's stored in the string. And this is also called, I didn't mention it before, but it's also called dereferencing it. When we dereference a pointer, we use that asterisk in front of it, and that's getting to the actual value. So on all of these lines that you see here, we would call that dereferencing the pointer, and dereferencing the pointer gets you to the actual value that's stored there. And so just kind of keep that in mind, that when we do this using the asterisk, something like asterisk p str dereferences the pointer. And when you dereference the pointer, that allows you to access the value that's stored in the pointer. And what happens when you work with strings is you also have the size variable that you can use, and you can determine the size using the pointer, or you can use the size using the variable pt, just a pointer arrow string. Sorry, I said that wrong. And so take a step back. Sorry about that. This line, if you notice, there's parentheses around the pointer string. And the reason for that is you want to get the value that's being dereferenced. So it's actually taking score, and then it's taking the size of that. The other way that you can access a member function, the dot size, they're just showing you here. Another way to access that member function is to use an arrow notation. And that arrow is literally typing the minus sign and then a shift key with the greater than symbol. So there's two different ways that you can access member variables using a pointer. If you use this first version, you need to make sure that you dereference the pointer and put it in parentheses. If you use the second version, you don't have to dereference the pointer, but you do have to use the arrow notation and then call the member function. That is a brief introduction to pointers. Most of you will not use these, but it is a topic that you should at least have seen or heard about. And you will see it in the zoo example program in a little bit. And at that time, the way that it's employed there, It helps with polymorphism, and you might decide that you want to use pointers. So this is just a little introduction